All right, so you should by now have something that looks sort of like this, but with your room, where you have the audience areas drawn for your theater, okay? And in my case, I had to draw I had 5 surfaces to draw, 4 audience areas, but one of them I had to draw using 2 shapes, which is pretty typical. So what we've got to do now is we have to create what's called the listening planes. So I was very specific last time to tell you that you draw the floor, right? You're not drawing the chairs, you're drawing the floor. And somebody, I think, even asked, yeah, but aren't the ears up higher than that? And I said, yes, they are. And yet, you draw the floor, okay? And here's why. Because what you have created here are just perfect absorber, wall/floor surfaces. Sound does not get plotted on those, okay? Sound gets plotted on areas. So in E's terminology, what you have drawn are called faces. Sound gets painted onto areas, as in audience areas. This is a German program, so I imagine that there's probably the translation back to the German. There's probably the words in German probably make more sense than face and area do, but that's how they translated it. So what you got to do is you have to create the areas now, as in audience area. Okay, and you do this by clicking on the face and then making sure it's yellow. And you do this by making sure you're looking at it from the top. So go to the plan view, for example. And if it's yellow, that means it's drawn right side up, okay? Because it's going to draw the audience area above the face based on which side it thinks is up. And yellow means up. White means down. So if you click on your face and it is white, that means you drew it counterclockwise instead of clockwise. And when you draw it counterclockwise, you're telling Ease, draw this upside down. Okay? So once you've got that, you're going to right-click, and you're going to select this option here that says Area Above Face. Let's see.
Mine is too, but it's like the words are in black, so I think you're able to click it.
You may not have drawn a flat surface.
What? I just clicked it and it let me open something, so.
So right-click on it. Yeah, you have not drawn flat surfaces. Remember when I said that you have to draw the surfaces using only 4 points?
Oh.
So you have drawn yours using 6 points, which means it is not perfectly flat. So what you need to do is delete all of these, and you need to draw them using 4 points each, and then they'll work.
So I should have like little boxes
Yeah.
instead of these like
Yep.
rectangles?
So you would go clockwise, boom, 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 boom. There's one, another one, 1, 2, 3, 4, 5. There's another one.
I did it like that.
Using 4 points only. Okay. Did yours work? Yes. Okay. Anybody else having trouble getting the area above face thing?
So I need to, do I delete my points and redo them?
No.
Or delete the face?
Delete the faces.
Okay.
Yep. Use the same points, assuming the points were drawn correctly. Okay. Everybody else, did that work? Okay. So what I'm going to do is I'm going to go ahead and make mine, and I'm going to say area above face, and I will click OK. Now, if I look at this in an angle view, you see it has now drawn some new surfaces above the floor. That is where the ears are going to be. So I will do this for the remaining ones. Area above face. area above face, area above face. Okay? See that? So now you have audience listening areas. So that is the green surface that is above the floor that's approximately where the ears will be when people are sitting down. Now this is the distance that is drawn is a variable that you define in ease. It defaults to something. I can look and see. Not sure where that is actually. It's somewhere. Somewhere there's a preference where you say this is where the audiences are this far up above the floor. Eric?
Yeah, just like when you say like area above face, like does it create that surface area that's like generally accepted when where people's heads are?
Yeah, that's what I'm saying. Is that distance is a definable parameter. You can change it. It defaults to like 3.5 feet or something, which is about where most ears end up being. I wonder if it's over here. Yeah, I'm not sure. I'd have to dig around to find it. But there's a place where you can change that. Like if you're doing a thing where everyone's going to be standing up instead of sitting, then you would want to like make it be up higher, right? Okay. So we've got that. Now, once you've done that, you're going to want to save, both in the Edit Project app and in the main window.
So we right click in the area and then area above face.
Yep.
And then what?
Does it work now?
Yes.
So then it should bring up a little window and you click OK.
Oh, okay. I just picked one.
Yeah.
Okay.
Yep. So just click OK.
Okay.
And do that for all of them.
Okay.
All right. Everybody else got that? Yes.
I had a pop-up that says face mismatch.
Face mismatch.
Yeah, or hole in room.
Okay. So click OK. And let's look at your room settings.
Okay, so just cancel for now.
And go ahead and click OK. So go to Edit and Room Data. Now it says Room Open. Is it possible that your surface is not flat?
I only used the 2 points from the CAD, and then they're the symmetrical.
So
I did the area.
face mismatch. So if you let's check your points. So if you go, let's go in here and click on this Show Vertex Table.
Oh, wait, I should save in the other thing really quick, shouldn't I?
Yeah.
Let me do that real quick. Okay, I'm back to this.
Okay. So it's odd to me that, oh, it's just wider, I see. Why is there 6.67? Yeah, it should be flat. I don't know why it would be giving you trouble. The whole in room thing is like if you don't have that room open option done, then it can give you that kind of trouble. What you may want to do is delete the surfaces and draw them again and just see if that makes it happier. All right. Once you've got this, now it's time to start putting loudspeakers in here. So let me show you how that works. The first thing you want to do is you want to go and take a look at the CAD drawing and kind of figure out where, what is the design you're going to try to achieve here. What ease does is ease can help you to make a good decision. But it is a lot of work to do if you are going to make your decision first based on just what you want. Then you're really wasting time with ease. The whole point of ease is, okay, I have this idea, or here's what I'm trying to accomplish. Now let me try and get ease to show me the results of this decision, and then you can make new choices or refine those choices. So what you do need to kind of think of is, what is the type of design I'm going to try to achieve here? In my case, I've got 3 to 4, depending on how you count them, seating areas here. And I think that I want to try to do a center cluster. I want a location for what's probably going to end up being at least 3 loudspeakers, that one pointed at each of these 1, 2, and 3 sections, that ideally is coming from the same location over the stage. Okay, that is, important to me for the purposes of what I'm trying to do. So if I look at the section view here, I just need to kind of figure out where that's going to be. Now I've got a catwalk here and a catwalk here, and some roof steel here, and directly over the stage is basically there. And I'm picking this height, because if I go a whole lot higher than that, then I'm going to be running into the catwalks. Okay, so I'm going to try to hang it at about that height. Okay, I'm kind of just picking something here for no particular reason other than, well, I kind of want something that's directly over the stage. Okay, and so this is a spot directly over the stage. So I'm just going to hover over that, go back to ease, and you're going to activate the Insert Loudspeaker tool. So you click on this. It's the 3rd one down on the left. And again, you just sort of click anywhere, and it brings up this window. And you want to put the location. Now the location in my case for this first one is going to be 0 on the X, because it's sitting on the center line. Right? Because I'm putting it on the center line. Now in your case, maybe you're putting yours in a different place, but in my case, I'm putting it on the center line. So I just need to know the Y value, which according to CAD is -36.3525. And the Z value is like, how high up in the air is it? CAD is telling me it's 21.8333. Okay? So that's where it's going to go. Now I need to pick a loudspeaker that I'm going to use. Are you ready? Everybody watching with your eyes? I'm about to click a button that you're not going to know exists unless you're looking. Okay? Down here in this window, there is this button right here that, if you look really carefully, has a ... labeled on it. And there is no tooltip to tell you what that does. But that is the button you click to get loudspeaker models. Okay? So you click that button and it brings up this window. Now right now, I only have one loudspeaker loaded here, and it's called Sphere. And every ease project gets this by default. And a sphere is just a completely fake, imaginary, omnidirectional sound source, right? It just shoots sound equally in all directions, which such a thing does not actually really exist. But it's just, if you just want to plot straight up inverse square law from point to point, that's what this thing will do, okay? But if you click Browse, you see where the Browse button is? You click Browse, and it will open up the database. And it should default to this folder called Global Speakers. And inside of there, you will see folders for different manufacturers. Now, this was installed when you installed Ease. It installed this library that the people who make Ease have collected these files over the years, some of which came from the manufacturers, some of which came from third parties, and it's there. You can also download Ease files directly from a manufacturer for their stuff. So you can go to D&B's website, for example, and you can download their Ease library. And you would install it just like it was a program on your computer, and it would put those files in here. So when you loaded this project database, you would see them. Sometimes you will find that the loudspeaker definition files that ship with Ease have problems. They're buggy or they mess things up or whatever, and you want to be very careful about that. And if you find one that does that, delete it from your project and then go to the manufacturer's website and re-download it from them and install it and see if it works better. Okay? So I am going to go here to EAW. Now I happen to know that this particular theater owns some EAW loudspeakers. And they have some things called JF100s, JF100Es, as in JF100E, little e. So I want to see what those would do if I hung them in this spot. So I'm going to go to the EAW JF100E. You can pick that if you want, or you can pick something else. Maybe something from the project you did before when you did this manually. You just click on it, and it.
Yeah, it's like I double clicked on it.
So if I double click, go back, it should default to global speakers.
Yeah.
Okay, and then you go down to whatever manufacturer you want. Watch what I'm doing. Watch with your eyes. I'm going to scroll down to the one I want. I'm going to double click on that, and it opens it up, and now here's the list of folders inside of there. So I'm going to go find the JF series, which is right there. Okay, I'm going to double click on that, and now I get a list of the JF series SPK files. Yeah. Okay, so I'm going to get the JF100E, and I'm going to add that to my project. And then I'm going to hit close. And now it's sitting here in this list, and now I can select it as a speaker model. So once it's highlighted, now that's the one I want. Now you get these little graphs here that show you maximum SPL per frequency for this loudspeaker, which this one looks like maximum SPL is probably around a little over 121, looks like 121.5 dB SPL, and it's just, that's across all the frequencies. I don't know if that's right, probably not. And then it also gives you a directivity index, which, if you remember that term from when we studied directivity, just to kind of show you what it does. Okay? So this thing, it gets pretty directional for, you know, some 1500 hertz above, and gets less and less directional the lower you go below that 1500 hertz. Okay? That's pretty typical. So I'm going to click OK. And now you'll see down here in that speaker model field, it has the name of it now. Okay? Now, the next thing I'm going to want to do is I go over here to this level area. I want to click this button that says All to Max. And what that's going to do is it's basically going to crank up the volume of this loudspeaker to whatever the loudest it can do. Okay? So that just gives you a lot more resolution on the graph when you plot this. So I'm going to click All to Max. If you do Flat Max, what it's going to do is ignore the frequency response information for the loudspeaker and just put every frequency at the same level at whatever it decides is the loudest it can do. But if you do all to max, it's actually going to do all to max per frequency. Now, in this case, this particular file, which is probably not a very good file, seems to think that every frequency is going to be the same loudness, which of course it is not. But that's the data that we have here. So I might want to go and get the one from EAW and see if it's any different. But we'll work with this one for now. So once I say all to max, I'm going to click Apply. And then I'm going to click OK. And you see it there now. Now, one of the things that is a little frustrating is, and you can kind of see this, is that it has little vertex labels for every little piece of the box that is drawn there. So this is why you want to then go ahead and, once you've drawn everything in your room, go ahead and switch the vertice labels off. And that way you can kind of see what's going on. Now what you'll see here is there's a little wireframe indicating the cabinet itself. And then there's this little thing that's yellow indicating just the generic sound source. Those are separate bits of data. The actual cabinet that is drawn has no effect on how the sound gets plotted. They are separate things. They're even stored as separate files. Okay? So don't get too worked up about what that little box looks like when it's drawn. It doesn't actually mean anything. And it has nothing to do with what gets plotted. Okay? It's just meant there as a visual representation. And sometimes, because it's stored as a separate file in the EASE database, sometimes it's not even right. Sometimes the box that is drawn is not right. It's not how the box would look if you hung it in that way. It might be flipped 90 degrees or something, or it just, so don't get too worked up about the box. The box doesn't mean anything. It's just there to look pretty. Doesn't mean anything, though. Not affecting your data. Okay?
Question.
Yes?
I did the area face, my stuff turned green, but it doesn't have two layers like that.
Did you go into like the 3D perspective view? Go there and see if you can see it above there. This little diagram. Yeah? All right.
Thank you.
Okay, so I've got this thing sitting here now. Yes?
In the edit loudspeaker, mine has a red light instead of a green light. Is that
Um,
I did sometimes.
did you hit apply?
I did. Stayed red.
What loudspeaker did you pick?
The MK2366
From what company?
EAW, because that's the one that I had put in my. I pulled up my old project. Just
Gotcha.
Because why not?
I think I know what that's about.
Does that mean bad file? Go find another one.
Not necessarily. Go ahead and click OK. And try to save. Yes, OK. So the error you're getting is you have an asymmetrical speaker model used in a symmetrical room. So the way that EAW stored that data file, it was not symmetrical. Or there's something about the loudspeaker itself that is not symmetrical.
Sure.
Which means,
So it can't resolve that issue.
right.
Okay.
So what you have to do, you just click OK, and that's fine. You can go ahead and save it for now. And what you're going to have to do is turn off your room symmetry. So go ahead and click OK, and go to the Edit menu and Room Data, and uncheck Room Symmetric. Now, once you do this, there's no going back.
Oh, excellent.
There's no going back to symmetrical once you go unsymmetrical or asymmetrical. Okay, which means you got to make sure you've really drawn everything.
Oh,
Okay.
I hope so.
But so there's no longer going to it's no longer going to make automatic copies of everything
Okay.
on the other side of the center line.
Okay.
So
Wow.
just know there's no going back. But you have to do it if you want to use that loudspeaker. You're going to have to do this. Yep. Because what it's going to do is all of the mirror image points, vertices, don't actually exist in your file. They are just implied because your room is symmetrical. If you turn that off, it is going to create actual vertices.
And so turning it back on would force it to duplicate it again.
Yeah.
And it's like not worth
Yeah, you can't do that. So, all right. So I'm going to click OK, and this seems all right. And now I need to aim it. Now there's a few different ways to do this. If you right-click on it and go back to Properties, you can put in, there's a section for angles where you do a horizontal, vertical angle, and you can also do a rotation where you can kind of rotate it 90 degrees or something, which sometimes you'll do that in real life. You'll take something and hang it 90 degrees sideways or vertical or something. So you can put that in there. That's a way of doing it. The way I like to do it, at least right at first, is I'll right-click on it. Now watch carefully. Watch with your eyes. Watch. I'm going to select loudspeaker aiming. Now, what happens is this window pulls up, and my head is now inside that loudspeaker.
Wow.
And I am looking out the front of the loudspeaker to where it points. Okay? And you want to click in here at the spot on the audience where you want this thing to point. So I'm going to point it at the back row of that first section, of the closer section to the stage. Because right now it's pointed straight out to the back row of that back section. So I'm going to click here to point it there at the back row of that front section. Okay? I'm going to start there and click and just close that. And now I'll save. And I'll save. Okay? How are we doing? Everybody got a loudspeaker loaded and aimed?
So I have a loudspeaker
Hey, I
wrong
do it.
location, and I don't know how to edit the properties.
You have what?
So I have a loudspeaker, but I have it below the seating, so I put it in the wrong area.
Oh. So if you just click on it, right-click on it, and go to Properties,
So what?
you can change the XYZ coordinates of it.
When I right click it, I should see properties. I'm guessing I'm using a different tool that.
Let's see. Where is it? So yeah, click on it there. Oop. No, don't right-click. Just click on it. There you go. Now right-click and go to Properties. Now you can fix it.
So
Okay.
Jason, ideally, with this kind of seating, would you maybe want like X0, Y0, and then like put in the Z coordinate where you would want it, like if you were doing this from the ground plan? Because that's what I've done so far.
Well, it depends. I mean, you got to figure out what this thing does. Ease is going to help you figure that out.
Okay. Yeah.
Okay.
So, yeah, I'm
Right.
just like I'm about to do the loudspeaker aiming, and like
Yeah.
I want to aim it at the ground right there, right? I mean.
Aim it at the back row where the ears are. There you go.
Yeah. So I mean, this thing right here, this is not necessarily what they want, right?
Who's they?
The audience wants, because like the front row is not going to be.
You don't know that yet. You're jumping like ahead 5 steps here. You have no idea yet what that loudspeaker is going to do.
Okay.
Okay? We haven't done that part yet.
I'm trying to apply what's been learned previously in this course, and
Yeah, but there's no you don't have enough data. Like it hasn't shown you what it does yet. Right? So don't jump to the conclusion yet. Let ease show you what it does first, and then you can decide that. Then you can decide if it's right or wrong. Yes.
Going back to the symmetrical room.
Yes.
If I were to put a loudspeaker off the center room,
Yeah.
it would create 2 loudspeakers.
If room symmetry was still turned on, then yes.
In my case, I gotta go do that myself.
Correct.
That way you turn it off.
Correct. But that's pretty easy because you could just put one in and you could click on it, and you can actually, there's a duplicate function. Yeah, and then you can just invert the y-axis.
Yeah, just change it.
Or the x-axis, yeah. Okay, so once you've got that and you've saved in both places, now you want to go back to the main ease window, okay? And here's where we're going to answer your question, Eric, okay? So you're going to go to Calculations, and you want to do Area Mapping. Select Area Mapping from the Calculations menu. It brings up another program in the background. And you click on that, and there it is.
Area mapping is here.
Everybody will look with your eyes. Calculations, Area Mapping. All right, So it makes this little thing. I'm going to make this bigger because that's really tiny. And what it's showing you is just a plan view of of your room. Okay, so you're just looking at it down from the top. Okay. Now this row of buttons here are all the different properties that the ease will plot and predict for you. There's very few of these that are available to you in an open room like this. Like it's not going to be able to plot clarity, for example, without being able to calculate reflections. It can't calculate reflections if there's no walls and no ceiling and all that kind of stuff. So a lot of these things aren't available to you. But if you went and actually drew the entire room, like all of the surfaces in the entire room, and made a completely sealed box and defined surface materials for all of those walls and floors and ceiling and everything, then ease would be able to pretty accurately predict exactly what will happen. Even to the point where it can generate a transfer function or an impulse response and you can put headphones on and insert a virtual listener in the room, and you would hear what it sounds like in that room. In that way, if you built that building that way and put that kind of sound system in it, it would tell you what it would sound like. It's very cool. But requires an awful lot of data input to get that kind of output, which we're not going to do. All we're going to plot is direct SPL, and it's this one. Everybody looking? So there's this little icon that looks like somebody being, shot in the head with an arrow, like a bow and arrow. That's not what it is, but that's what it looks like. It is, in reality, what it is showing you is the sound. The arrow is the direct sound going straight to the listener from the sky. Okay. So, but that's what that is. So you're going to click Direct SPL, and it brings up this little window, and you need to pick what frequency you want to do. Okay. I'm going to stick to 4 kilohertz for now. I find that 4 kilohertz is usually, that's a frequency in most cases that is pretty well controlled by the horn in a pretty consistent way. If you get much lower than that, it starts handing it off to the low drivers and the directivity gets a little wonky. So when I'm trying to make decisions, like am I on the right track, I'm looking at 4 kilohertz in most cases. So I select 4 kilohertz. Now you need to select which loudspeaker you want to use. So down here it says loudspeakers in use. You're going to hit this LSPK button. This LSPK button. And it will bring up a list of all your loudspeakers. And right now, I only have one, and you probably only have one as well. So you just click the one that you have, called S1, and click OK. And now it's listed as one of the ones that's in use. And now you click OK again. And it paints this really pretty picture. Yours is all black? That probably means that your loudspeaker is underneath the listening surface. Or you didn't hit the full Alta Max thing. One of those two options.
I did it again because I changed the speaker to match my assignment.
Okay, so close that and let's go back to your room edit view. Okay, so where is that? Go to Properties. Oh yeah, see, it's on the floor.
Oh.
Go to Properties. All the way at the bottom. Properties. See, your Z value is 0. You got to get it up in the air.
So should I flip these then?
No, you just need to get it up in the air where it would be. So use your CAD file to figure out how far up in the air should this be from the floor.
I put my point up on the plaster line up here, and that was my distance. I didn't have a Z.
Well, if you measure from there to the floor, what is...
Whoa. Hello. Here to the... I did mine to this.
Okay. So what is it?
That's a 19.
All right, so put that in there. Okay. So what is this showing you? It's going to give you this little key over here. And hopefully, do we have any color blind people here? If you have trouble with color, this is going to be challenging for you. I think there are some ways you can make that easier. So if you have trouble with this, let me know. But one of the things I like to make sure I turn on is this little button here, which turns on what's called the ISO lines.
Should I close the mapping on and open it again since I changed it?
You just have to save in both the edit view and the main view.
I saved it, but it didn't
Okay,
change.
so now click that button.
This one.
Yep.
Oh, I gotta do this again?
No, you're good. Now just click OK. There.
Thank you.
Okay. So if you turn that, if you do the other option, it does this, which I don't think that's very helpful. So I like to do the ISO lines because the ISO lines tell you when you have a 1 dB change. And that helps those of you that might be color challenged. This is one of the ways that you can get through this, is it will draw you a line at the edge of each color with a label. So like inside of this circle, that's the 88 dB SPL zone. Inside of that circle is the 87 dB SPL zone, so on and so forth. Now the goal that I'm interested in achieving, at least for this area where I'm pointing this thing, is I want a 6 dB range. So the loudest zone is 88, and the quietest zone is 83. That's 5 dB difference.
Is this,
I'm probably going to get paid.
excuse me, Jason?
Mm-hmm.
I don't know what I did wrong. But like the little circles, I think I might have aimed it wrong. Cause I don't have like the center, like it's just lines.
So where is it? Go back to your drawing. Let's see. Where is it? Oh, it's all the way out on the side?
There, I guess.
And
Maybe I should change.
and where is it? Let me see the actual coordinates.
I never changed these. I only messed with these.
Yeah, ideally it would be pointing at the audience. You're coming out from the side, so I would.
So should they be closer then?
Well, I would put it on the X0
Okay.
because that would put it on the center line,
Okay.
and then your Y should be where it is, because you know where did you have your origin when you drew the services? Where was your UCS?
For this, I did it here, and mine was the intersection between the center line and the plaster
Okay,
line.
great. So if you're okay, great. So if you go to your section view then, and you're drawing, it looks like you're drawing them on the plaster line. So you're going to put 0, 0
Oh,
in
okay.
there.
Okay. Oh my gosh.
And yeah, you're going to want to re-aim it.
Re-aim it. So hit OK and then go
Well,
to aim.
hit Alt to max.
Not to max.
There you go. Click apply. And let's do horizontal angle to 0. There you go. Now try it. Now hit save here and save there. No, no. Now go to the mapping one and click that.
This.
This recapture.
And then OK.
Yep. So move that out of the way. There, now you're getting somewhere.
Okay.
You're plotting at 500 hertz, so if
Well,
you,
that, I was just going by like the first one on the
yeah,
assignment.
so go to 4 kilohertz, like I said, and then it'll look better. Yes, Eric.
Yeah. So like, I'm trying to like change the positioning of the speaker just to see if like.
Okay, don't get ahead of me.
Oh.
Wait a minute. Does everyone have this?
Yes.
Have their one loudspeaker plotted and colors are painted on the surface?
I just have green, man.
Okay.
Just green.
So in this case, I'm looking at this and I'm going, okay, well, this is maybe okay for that one, for this section here. Seems to meet the goals. So I need to do something now for these side sections. So I'm going to go back to my room edit view, and I'm going to right-click on this thing, and I'm going to say duplicate. And I'm going to make 2 more of these, one pointed to each of those side sections. So I'm going to say duplicate, and it says displace by how many feet? Well, I want to go like, because right now this thing is sitting right on the center line. So I want to go like 2 feet over to the side. So I'm going to displace by 2 feet on the X, which I think ought to do it. I'll click OK, and there it goes. So it's made a copy of it. And you can see them, all 3 of them lined up there, all pointed the same way. But what I want to do now is I want to take it and move it horizontally. Rotate it horizontally, okay, by 90 degrees. So I'm going to, in a horizontal world, I'm going to say 90. And I'm going to click Apply. And now I can see over here that it got re-aimed, right? And it's now pointed there. Yes?
Which box do I click to get back to the frequency?
To what?
To get back to change the frequency.
You have to replot the direct SPL.
So go back to speaker aiming.
No, back. It's here. So you would go in here and select a new frequency, and then replot by clicking this button up here. Look with your eyes. That button there. Okay. So now what I want to do is I want to aim this one. So I'm going to right-click on here and go to loudspeaker aiming. And it looks like it is pointed now at that side section. So I'm going to point it down at the back row of that and just see what happens. I'm going to hit save here. Actually, I had the thing open. Let me see if it kept it. Oh, yeah, I got to redo it. Hang on. There we go. Put it there. I'll hit save here. I'll hit save here. OK. Now, if I go back over here, you see how there's this yellow outline around the window now? Yeah. This is E saying, hey, something changed in the data. What do we do about that? And you can click this little button in the top left of that toolbar, which if you hover over it, it says acquire data. And it basically tells you, yeah, just reload, right? Just now that you have saved, there's a new data in that file. Just click that, and it'll say recalculate the map. Yes, please. It says what frequency? 4,000 hertz. I click OK, and there it is. Now it's still only plotting that one loudspeaker because I didn't change the parameters of the plot here. So if I want to see what those side ones do, I'm going to close that window, and I'm going to click on that direct SPL button again. And this time, for loudspeakers in use, I'm going to unselect S1, and I'm going to select S2 instead. No, you can do more than one. We're doing baby steps here. So I'm going to pick a different one, and let's see what it does. Okay. So try that. Load a second one in, and point it in a different spot. Or
just do that individually apart from the first speaker?
Yeah, just load a second one in, and put it in a slightly different spot, or aim it in a slightly different way.
And just focus on that one when you're doing this?
Yeah. Do exactly what I just did. Make another one, and then select that and plot that one. You got to click the direct SPL. And now select which loudspeaker you want. S1. Okay, now click OK. There you go.
So then, now
What loudspeaker is this, by the way?
I have the JF60?
Ah, that explains it.
Is this a bad option?
No, it's just like that's basically an omnidirectional loudspeaker.
Oh.
And at that distance, it's going to have no directivity. That's why you've got like just one color across there.
Oh.
Yeah,
So for the sake of the assignment, should I choose a different one?
you can if you want to, but for the purposes of this assignment, that's not super important. Okay, yes, Lee?
So what I mostly see is like green. Shades
Yeah.
of green.
That's fine. And you can see the lines are telling you that there's a difference, right? Other questions?
Am I allowed to do it?
Right now.
So subwoofers are basically omnidirectional. Okay? And so they're not going to, usually you're not really plotting directivity for subwoofers because they don't do that. So I would stick to the frequencies that it's actually possible to control, which are generally 500 hertz and above. Anything below 500 hertz, there's very few loudspeakers that are going to control that in any meaningful way. Okay, other questions? Anybody else got any problems?
I'm a little bit confused about what I've done. Yeah. So I'm focusing just on the S2, and it's like, is this covering this area right here?
Well, that's where you've aimed it.
Yeah.
So you've aimed it at that spot, and so that's putting most of the sound there.
So this spot right here is this?
Yeah. Yep.
Oh, so it's covering like this area right here.
Yeah. So that's where you pointed it.
I wanted to.
Okay. So let me Let me just look at this all together now, with all these ones I've made. So now I'm going to click on the first one. I'm going to replot. I'm going to click on the first one in the list. Everybody watching with your eyes. And then I'm going to shift and click at the last one on the list, and it'll select all of them. I'm going to click OK, and I'm going to plot it again. And what do you suppose is going on here? Why is it looking all ripply like that? Yeah, and what happens when multiple loudspeakers overlap or multiple sounds overlap? Comb filtering, right? It's comb filtering, right? Because these are not perfectly directional, and we could see even when I was plotting the one at a time that there was some overlap, right? So there's some comb filtering going on. Is it devastating comb filtering? No, not really. But you do have the option of ignoring that if you want. And you do that by, when you click on the direct SPL, you go to this calculation thing and uncheck interference sum, and it will not plot the interference. Okay? Just be careful with that. Sometimes you need to do that. A lot of times you need to do that. But sometimes you can check that to pretend like problems don't exist, which you don't want to do. So there you go. There it is without the interference sum. So let's see where I am now. So I've got a peak value of 91 dB here, and 84 dB there, 81 dB there. So that's a range of 10, right? That's not great. I wonder if I could get this center one to cover this whole thing better. What if I aimed it all the way to the back row of this rear section? Would it work? I don't know. Let's see. I'll close this. Let's go back. And I will click on S1 and re-aim it and point it up the back row. And let's see what happens here. And just for now, I just want to look at that one by itself. Not terrible, is it? So 86, 5, 4, 3, that's 3, 4. Yeah, it's basically doing it. That's within 6 dB. Okay, so let me turn the rest of them on and just see what happens.
Is there a reason why love scripting will not pop up? I see it, I can click it, and then it just flashes.
I don't know. Is it hidden behind there somewhere? Like if you close your mapping window?
Closes.
Yeah. So I would go ahead and save your data. And then save again. And now try it. Now, so try to pull up loudspeaker aiming now. So I would just maybe save this, close the program, and load the file again and see what happens. Okay. So if I turn these all on, I have a bit of a problem. It was fine when I was only considering this, but now I've got this 91 dB hot zone here, and I go down to 82 there. So I'm not really within that 6 dB range. So what I want to do here is these ones that are pointed to the side, they're just closer. And so they're louder because they don't have to travel as much through the air. So I'm going to turn them down and make them quieter. Okay? And in real life, there's a number of ways of doing that. But in ease, here's how I'm going to do it. Okay, good. So I'm going to go back to here, and I'm going to click on the side one. And I'm going to go to Properties. And here's the properties for one of those side fills. And I'm going to click this -1 dB button. And that will turn the whole thing down by 1 dB. And I'm going to click it again. And I'm going to click it again. I'm going to turn it down by 3 dB. I'm going to click Apply. And then I'll save. And I'll save. And then I'll go back to area mapping, and let's see what we have now. With everything selected, yes, turn it on. Okay, we're getting a little bit better. The hot zone here looks like 86. It's 88 here, so I'm going to turn them down by 2 more dB and see if I can't even this thing out. So we'll go in here, and I'll click that -1 2 more times. 1, 2, apply, save, save, and then I'll acquire the data, recalculate, okay. Let's see. Hey, look at this. I think I'm onto something here. So I'm 86 there, 86 there. I go all the way down to 82 there, 82 there. So this might work. Okay. So the thing I don't, that's not the part I want you to take away from this, is that Jason did that really fast. The part I want you to take away from that is that I did not just accept my first premise. Okay? I did not say, I have an idea. I'm going to make a 3-way center cluster out of JF100 E's, and I'm going to point it in there, and I'm going to plot the E's and put it in my paperwork so Jason will get off my case. Right? No, I said, I have an idea. I wonder if it's a good idea. And I used E's to show me whether I had a good idea or not. And I thought, it's close. I'm within capture range of a good idea here. What would I need to do to turn it into an actual good idea? and you analyze what ease shows you, and I said, oh, okay, well, this one I'm going to aim up a little bit and see if I can even out that coverage in that one area. And then those side ones, I'm going to make them quieter. And I think if I did that, I could level this thing out and get this whole area within 6 dB. And sure enough, I did. Okay? That's what you're supposed to do with this tool. This is not a tool to just plot the decision you've already made and put it in your paperwork so that I'll stop nagging you about it. This is a tool that helps you to make a good decision. It lets you test your ideas, and it will show you the results or the consequences of those ideas without you having to call a crew, load up a truck full of equipment, go over to a space, get some riggers involved, and hang this stuff up there, wire everything up, get the amps programmed, measure all the angles and everything, make some sound, get smart acoustic analysis microphones laid out, and measure all the different locations. I mean, this would be a 2 or 3 day process to find out if you had a good idea or not. It's way easier to just do this. And ease will give you a pretty darn close estimation of what the consequences of that decision might be. And the important thing to understand is ease does not give you the answer. Ease did not tell me that I needed to tip this loudspeaker up a little bit and turn these ones down. It did not tell me that. It just told me what was going to happen if I did it the way that I said. I had to decide what that means. And the way I decided what that means and figured out what that means is I applied the principles I understand about loudspeaker directivity, inverse square law, all the things we've talked about so far this semester. I said, okay, well, this area is louder than the other area. Why is that? It's the exact same loudspeaker. I said, oh, it's closer. And inverse square law says if it travels less distance, it will get less quieter, otherwise called louder. That's probably the reason, because they're closer. Those seats are a lot closer than these seats. That's probably why it's louder. Okay, I'll turn it down. Ease did not tell me that that's what was going on. Ease just told me that that seat was louder. I had to be the one to say, I bet you it's because it's closer. And closer sounds are louder. And I had to be the one to realize, oh, actually, if I aimed that at the back row, then I could even this out because I'd get the dB loss over distance, but then when I get closer, I'd compensate for the directivity in the front row, and I'd even this out. I bet you I could get this thing to work. I had to figure that out, not the computer. So that's what this tool does. This tool does not give you answers, it just gives you data. You have to decide what it means, and then you have to make decisions about what you're going to do about it. And you should try multiple options. You should not just go in here and plot your first idea and lay it out there and put it in your paperwork and then show it in the look. If you do that, I'm going to be like, what the heck is this? This doesn't make any sense at all. You're not even within 6 dB. It's comb filtering like crazy. It's and because you didn't actually test for those things, right? So that's what this tool is for. Questions? Yes.
So, from a workflow standpoint, then, is it advisable to go into AutoCAD and make an educated guess? I mean, like we did with the first assignment, not necessarily do the math because Ease does math.
Yeah.
And then, plot that a couple different speaker setups.
Yeah.
Shift them around in Ease, and then do what you found is best in Ease, regardless of whether it correlates to
Yeah.
AutoCAD.
Yeah.
This will spit out the position and aim points,
Yeah, you can get that from Ease. So yeah, what I did in this case is I said, okay, I know the theater has these loudspeakers. So what would they do if I hung them in this place, right? Now, in your case, maybe if you're working on a project like for a show here, we've got lots of different kinds of loudspeakers in the shop, so you've got to kind of, well, which one do I pick? Well, yeah, you're going to make an educated guess, and I'm going to say, well, okay, like if I am going to hang something over the stage, that's going to be, there-ish. Okay, I need something that'll cover this center section. Well, what would that look like? Well, maybe I just kind of draw a line from here to there and just measure that angle. And That's it says 36 degrees. So total, that's going to be a little over 70, 75 degrees. So I'm looking for something that has a 70-ish degree horizontal coverage. Okay, I've just narrowed the options down significantly, right? So now I go through the shop inventory and I say, okay, what do we have that's got horizontal coverage in that range? 70-ish, 70 to 80, right, as I could say. And then you'd find a few, and then, yeah, you load them in to ease, you plot them, you see what they do. Maybe you even move them, right? You say, oh, I'm going to start here, but you realize, oh, well, if I moved it, it would work better. Great, move it. And then get it to work right. And then if you moved it, then, yeah, you go into ease, you get the actual location of it, and you put that in CAD. So, like, I can do that here. This is called, you click this button that says Show Loudspeaker Table. Yeah, Room Edit View. So it shows you here each loudspeaker, where it is located, and what angles it is aimed. And you can export this to a file if you want. I think it spits out a CSV file if I remember right, or you can just get it off of here, and it's like, okay, it's X, Y, Z. X is 0, Y is negative 36, and then Z is 21. Okay, great. I can put that into CAD. That's now the location, right? Other questions?
Question. For our homework, we just have to do that over and over? Like,
Oh, so for the homework, let's take a look at that, shall we? For the homework, if we go to assignments and we go to ease, here is the ease assignment. So you're going to use ease software to determine an appropriate center cluster for the theater linked below. You should turn in an ease archive zip file, which I will teach you, as well as PDF showing coverage plots for at least 2 different options. Basically, you are going to do the exact same thing you did for the paper option, or the CAD version that we did with polar plots. You can just do the exact same thing. You can just choose the exact same loudspeakers you did before, put them in the exact same place, plot them in ease, tell me which one's better, okay? Or if you want, you can pick different things. If you want to, if you realize that, oh, actually those weren't very good, I'm gonna try something else, fine, try something else. But I just want 2 different options. Yeah, and plot the coverage, and tell me which one's better. Okay. We have, let's go over schedule here. So on, where are we? Today is the 6th. So I haven't quite gotten everywhere I needed to yet. So I think I'm going to move this to the 13th because on Monday I need to show you how to actually like save the graphs and plot it into your CAD file and all that kind of stuff, and how to make the zip file and all that. So let's move the due date for this to the 13th, and we'll look on Monday at those last little bits of the project, how to do that stuff, and then you'll have between Monday and Thursday next week to get it turned in. Okay, does that sound all right? I had planned on 2 days to do the homework review, but we'll just have to move fast when we look at them all. Okay, because I haven't quite explained all the things to you yet. So we'll fill in the rest of the remaining gaps on Monday. So what I would suggest between now and Monday would be to go ahead and put your loudspeakers in, right? Go ahead and put them in. And if you come Monday with some loudspeakers in your file, and you can actually get the coverage plots out of that, then you'll be in pretty good shape. And then I can show you these last few steps. Okay? Yeah.
For that, where we're doing 2 different systems, can we just put them in the same file, and then when you
Yeah.
color
Yeah, and I would suggest like naming the loudspeakers. So instead of just taking the default names, I would just go into the properties and call them something that is something recognizable. So instead of S1, I would say center cluster center option 1, right, or something, and
And even if, let's say, you put both speakers in the same place, in the same location, like it'll just.
that's fine. Ease doesn't care. Yeah. Yeah. Quantum mechanics work in ease. Two loudspeakers can inhabit the exact same spot. They just do it so in alternate universes. Okay, any other questions? Eric?
This is something afterwards.
Okay. Anybody else? All right, so if you haven't already, please upload your ease license. And you've got a little bit of work to do between now and Monday. Okay?
There's a grad student in the shop today, right?
Should be. Supposed to be. Seth's in the shop. And just by the way, for this project, all I'm looking for is for you to demonstrate that you can complete all the steps. I'm not looking for good quality design here. I'm just looking for, can you complete all the steps of doing this in ease? The final project will involve you using ease to actually create something good. So I'm not looking for good yet. I'm just looking for, can you go from the beginning to the end of this process and actually spit out meaningful data? That's what I'm looking for. Okay? That's the standard. Can you wrangle ease to give you data? The final will be good data. All right? See you later.